Yeah. So the first one is integration of EZ divided by what? Z minus 1, then Z minus 4, then DZ. Oh, I don't know. Let me write it well. So FZ is equal to EZ out of X. Oh, not X. Z minus 1, Z minus 4, then DZ, and the radius of the circle is 2. So one more, anytime you're doing this question, make sure that you draw the circle. You draw the circle. Now, the radius of this circle is what? The equation of a circle is always given by Z minus Z naught is equals to R. So you can see that our Z naught here is 0, 0. So the center is 0, 0. And the radius is what? 2. So you can come and draw the line here. And then you have here 0, 0 is here. This is the center of the circle. The radius is 2 here, 2 there, 2 there, 2 there. Then you join this one here like that. This is our imaginary line, or whatever. This is our real. Now the other question to ask yourself: the poles here, poles. So we equate the denominator equals to 0. Z minus 1, Z minus 4 is equal to 0. So you can see that Z equals to 1 or 4. Now you ask yourself, are these numbers inside the circle or outside? You can see that when Z is equal to 1, it lies inside the circle. And when Z equals to 4, it lies outside the circle there. So it means that we say that according to the Cauchy integral formula, if a point lies outside the circle, the integration is 0. So if a point lies outside the circle, the integral is 0. Integral is 0 there. Now I hope you have noted some points there. First of all, we say that yes. You need to draw the circle, and the circle is given in this form. The circle is also given in this form here. This form here, like this one here. So now in this case, in our case, we are given that Z modulus is 2. So it means that the center of that circle is 0, 0, and the radius is what? 2. Then you show that circle there. Then you're going to find that Z equals 1, it is inside the circle. But Z equals to 4 is outside. According to the Cauchy integral formula, if a point lies outside the circle, the integral of that point is what? 0. So we don't care about it. That's okay.
Yes.
So now we have that information. Now I want to show you now the other way now of doing it now. So you see that the Z equals 1 lies inside the circle. So this is what you're going to have. And because this is a simple pole, will be very easy. So you can just do it like this one. You can have our FZ will be equals to, now, let me use another color. Can you see this part here? The part that is not, the part that is we are now considered z equals to 1. So this part here we write it as the numerator. So you're going to have EZ out of z minus 4, then divided by z minus 1, and then z is equals to what? To 1 in that case here, and then times what? Whatever you get times 2 pi I, like that. Now this one here means that we substitute where there's z on the top here. On this one here, where the z we put 1. So you're going to have our, what is e to power 1? So our final answer here will be, 2 pi I, then e to power 1, it is e to power 1 divided by 1 minus 4 is minus 3, okay? So the final answer will be minus 2 out of 3 pi I, like that. And that's the answer. Because the other part, the I lies outside the circle, so we don't want to care about it. You see, like anytime you follow those procedures, at least you get some marks, okay? Even if you're going to be confused at the end of the question, you get some marks. But you're going to do like main example, like 4 of them. So it means that you're going to understand before you finish, okay? Okay, so that's okay. Can you go to another example?
Yes, you can go to the next.
And this one is when the poles are simple. So like that, so you have to know that one there. Okay, let me go to the other one. Let me delete this one. Oh, I've seen the thickness of the line. Let me delete everything. So I'm going to erase this one. I go to the next page. So you have this page. So the other example is here.
I have a question without a question.
Yes, ask.
Umesema, you have said that z minus 1 minus 4 it is outside.
Yeah.
Yeah, you have said it's outside, and those outside integral is 0.
Yes.
And we have used it in the formula. We have used e power z over minus 4. Z to minus 4. So it means that we have used the nini.
Yeah, we use it, but you know, like it
So
if it was inside, let me show you if it was in how it could look like. It could have looked like this one here. 2 It could have looked like this one here. Sorry, the whiteboard changed in Zoom, so I'm learning to use it. I have just opened and found it has changed. So so it could be like, okay, it could be like 2 pi I. Then you're going to have our EZ out of EZ divided by z minus 4, then divided by z minus 1, then z is equals to 1, then plus 2i, this one here, then we are going to have ez out of whatever, we have z minus what, 1 now. But here z will be z equals to 4. Z will be equals to 4 in that case. You see that one? Yeah. But now this one here was 0. This was 0 because the z minus 4 was outside, so it was 0. That's why it's not there. Yeah, but you're going to do another one, you see. Let me do another one here. Yeah. So the other one is integration of ez out of z squared plus 1, then dz. So first of all, we need to get the poles. We say that the poles is when the denominator equals 0. So we're going to have z squared is equals to minus 1. We take the square root. So z equals what? Plus or minus what? I. Is that okay? So you find the poles first. Then now the other step, you have to draw the circle. You draw the circle, then you see. You draw the circle there. So what was the center of the circle? We have been told that this z was equals to 3 over 2. Of course, the center is 0, 0. Here you can see the center is 0, 0. And 3 over 2 is 1.5. So here is 1.5, 1.5, 1.5, 1.5. We draw this circle there like that. 1.5. So this is our imaginary line. This is our real. So where is I? So I is somewhere here, still here. And the other I is somewhere here, minus I. So this is I, and this is minus I. You can see that the 2 points lies on the circle. The 2 points lies on the circle. Now, if you know that one here, then you're going to have, you see this one here. I don't know whether when you know that when you factorize this one, you get z minus what? I, and then z positive I. Do you know that? Hmm? Like when you have z squared plus 1 is same as z minus I, and then z positive what? I, like that. So now we are going to have our answer as, so our answer will be 2 pi I. Then you're going to have like ez divided by, we take one of them, that is z positive I, then divided by now z minus I, like that. Then this one, when z equals to I, like that. Z equals to I, like that. So then we substitute. When you substitute, what do we get? When you substitute this one here to this one here, we get our 2i, this one here, 8 power I, and divided by what? By 2i. By 2i. I, like that. Then positive. So this one, because the other one is still inside, you're going to have 2 pi I. Then ez, we take the one that we are not using. That is z minus what? 1. Minus I, that is. And then divided by z positive I. And what you are substituting is z equals to minus I, that is. So we substitute. So when you substitute, what you get? 2 pi I e to power I divided by minus 2i. So there I'm going to have 2 pi I, 2 pi I ei out of minus 2i like that. And then you can simplify. You can see that these two can cancel out. This I can cancel this I, which is here. This I can cancel this I here. These two can cancel these two. These two can cancel also this two, which is here. So you're going to have the final answers. Pi, then ei minus ei like that. So that's the final answer for that one. Okay, is that okay? You can go to the other question. Oh, you can't see anything. Okay. So let me try to change the pen here. So there's somebody who was saying that he's not able to see, so I think you can still do it again.
Yeah, you can do it again.
Okay, let's do it again then. It was what? It was F Z is equals to EZ integration. EZ divided by Z squared minus plus 1. Then dz. Then you see that when you have z squared plus 1, it is same as z minus I, z positive I. That okay? Then you have the poles. Poles is when you quit the denominator equals 0. So we're going to have z squared plus 1 is equal to 0. So z squared is equals to minus 1. So z equals to plus or negative I. These are the poles now. The other step we see that is to do what? You sketch the circle. We have been told that this is a circle with the radius was what? Was z modulus was equals to 3/2. So it's 1.5. So here 1.5, 1.5, 1.5, 1.5. This is imaginary part. This is the real part. So you draw that circle there. Now you can see that I is somewhere here and minus I is somewhere here. So both of these points, they are inside the circle. That's okay. So then go to apply. We're going to add the residues together. Now from there, we are going to have, so our final answer will be like 2 pi I. Then now, what we are using, if we are using this one here, this one, we take EZ divided by Z plus I. Then in this case here, Z equals to, that is I here. This I, we get it from here. We can just put divided by Z minus I to show that this is what you are using. But now what it means that you're going to then plus, so 2 pi I, then you have AZ divided by, now in this case, if we're using this one here, this one, we put this on the below this, and you're going to have Z minus I, then you're going to have Z equals to minus I like that. And then this is over Z positive I. So this one doesn't matter, this one and this part here. This part doesn't matter, this one. So you just go to substitute now. So when you substitute, you're going to have 2 pi I. Then where the z, put I. So we have I for z there. So I plus I is 2I. 2I like that. Then positive 2 pi I. The other one here, this one here, we substitute. So minus I, we're going to have E minus I divided by minus 2I. Then we're going to have, we can simplify out. So that's, of course, that's the answer, but you can simplify this one here. This can cancel this one here. This minus can, this 2 can cancel this one. This I can cancel this I, which is here. This I can cancel this one, I is here. So the final answer becomes, become pi. Pi is common. Then E I minus E minus I like that. And then that's all. Now, you're able to see now. How is it that now?
Yeah, it's clear.
My phone went off, but I hope I'll follow.
Okay, let's go to the other, see whether you're going to understand the other one. Are you okay? Leave and go to the next one?
Yeah.
Yes. So the other one, it was like this one here. Okay, I don't know whether the first one you saw, but I can do it again. I can do the first one again with this board. Yeah. It was like EZ divided by Z minus 1, Z minus what? 4. And then DZ. And you're given Z equals to 2, like that. 2. These 2 here. And then I told you that the first process, the first step is to do what? You find the poles. So the poles is when the denominator equals 0. So you go to have Z minus 1, Z minus 4 is equal to 0. So we have Z equals to 1, all, 4. Like not all, let's Z equals to 4. Z equals to 1 and Z equals to what? 4. Then the other procedure, you draw the circle and you see. This is MI. This is the real part. The radius is 2, and you can see this one here. There's nothing here. So the radius is 0, 0 here. So this one is 2 here. There's 2 here. The radius is 2. This is 2 here. This is 2 here. This is 2 here. So we have 0.1 is somewhere here. 1 is here. You see 1 there? So 1 is inside the circle. So 1 is inside the circle. But 4 is outside. And we see that according to Cauchy integral formula, if a point lies outside the circle, the integration of that thing is 0. So it means that our answer will look like this one here, will be 2 pi I. Then you're going to have e to power z divided by z minus 4 over z minus 1. Then z is equals to 1. Then plus 2 pi I z out of z minus 1, then out of z minus 4, then z equals to 4. But we know that if the point is outside the circle, all this is 0. All this is 0. So there's no need actually to put this part here. That's why I just write 0. So then you substitute now the value of z with 1 here. So the final answer would be 2 pi I, then e to power 1 out of minus 3. So the final answer is minus 2 over 3 pi I e. And then you're done. So that's the final answer. For those who never saw number 1, that's number 1. So we got number what? We got number 3 there. Number 3. Number 3 look like this one here. FZ equals to, oh, not FZ. Integration of Z minus 2Z minus 1 plus 1 out of Z squared plus 2BZ. So which is the first procedure?
Finding the poles.
Yeah, poles. So when you keep the denominator equals 0, like when you do those steps, at least you cannot miss marks. So Z squared plus 2 is equals to 0. We have Z squared is equal to minus 2. So Z equals to plus or negative what? 2I. So these are the poles. So these are the poles. Poles like that. Now the other procedure to do what? You sketch the circle, and the circle was Z was equals to a half like that. Half. This is the real part, no? Real. And this is what? Imaginary like that. So now you can see that this is up to here is 1. And this is a real part here. This is 1 here. This 1 and this is 1. So also this one will be 1 there, 1 there. But now this one will not be 1 like these two eyes. These two eye, they are what? They are inside here, the circle here. Both of them. Because 2i is not a real part. There's a real part and the imaginary part there. So they must be inside the circle there. So yeah, they're going to apply both of them. So then it means that our answer here becomes what? And when you factorize this one here, what do you get? When you factorize this one? When you factorize this one here, you get Z minus root 2, and then Z positive root 2 like that. That's what you get. So it means that in this case, you're going to have our answers 2 pi I. Then you're going to have Z, 2Z plus 1 divided by, if we are using this one here, if you're using the 2i, we use the one that is minus here. So you're going to have the one that is positive. You're going to have what? Z minus square root of 2. And then our Z equals to 2i. Would be minus what? Or when it's positive, we use 2i there. 2i like that. And then positive 2 pi I. Then you have 2Z positive 1 out of Z minus root 2. Then you have what? Z equals to minus 2i like that. And then you substitute them. You're going to have 2 pi I. Then you're going to have what? 2 times I become 4i plus 1 divided by 2i plus root 2, then positive 2 pi I, then times 4i plus 1 divided by what? By minus 2 pi minus root 2 like that. So if something is not, you cannot factorize, it is difficult to factorize, then you can just leave it like that. That one there. But I'm going to get you another example which is more easier than this one here. And then we are going to do the one that in the cut using this method. There was this one here. There was this question. The one looked like this. Integration of 4 minus 3z out of z minus 1. Then you have z minus 2. Then dz. And our z